This is a problem from production, that is Cobb-Douglas production function. So the production function is given as Q equals A into L raised to alpha K raised to beta. Derive marginal product of labor and capital. See, when I explained Cobb-Douglas production function, there I have derived marginal product of labor. So here I will derive the marginal product of capital. So what is marginal product of capital? That is the change in the quantity produced with respect to a change in capital. That means we are keeping labor constant. So we have to differentiate the above equation Q equals A into L raised to alpha K raised to beta with respect to capital. So when you differentiate, that is dq divided by dk is equal to A into L raised to A into beta into K raised to beta minus 1 into L into alpha. So that is equal to beta divided by we can write K raised to beta minus 1, that is so we will write beta by K into A L raised to alpha K raised to beta, because K raised to beta minus 1, so that we can write K raised to beta divided by K. So what is A into L raised to alpha K raised to beta? That is Q. So this is equal to beta by K into Q, or we can write beta into Q by K. So what is Q by K? Q by K is the total product. So total product divided by K is the number of units of capital. Total product divided by the number of units of capital. So that is the average product of capital. So beta into, so we can write beta into average product of capital. This is the marginal product of capital, beta into average product of capital. So in a question, if you are asked to find the marginal product of capital, then we need the value of beta and average product of capital. Sometimes the average product of capital will not be given, so we have to find average product of capital. First we have to find the total product, then divide the total product by the number of units of capital, then we will get average product of capital, then multiply by beta, then we are getting the marginal product of capital. So in this way we can find the marginal product of capital, or just again when you differentiate this equation with respect to labor, you will get marginal product of labor also. Another question, suppose the production function is given as Q equals 2 K raised to 1 by 2 L raised to 1 by 2. What will be the output when K equals 16 and L equals 36? Just we have to substitute the values. So Q equals 2 into the value of K is 16 raised to 1 by 2 and L 36. So 36 raised to 1 by 2. So that is equal to 16 raised to root of 16, that is 4. So 2 into 4 into 6. is equal to 48. It's a simple question. Then what will be the output when k equals 16 and then second one, what is the marginal product of labor when k equals 16 and L equals 36? So here we have to find the marginal product of labor. If you want to find the marginal product of labor, then first you have to find the average product of labor. So what is the average product of labor? So here the total product is given. When k is equal to 16 and L is equal to 36, we have already estimated the total product of and the total product is 48. So average product of labor is equal to total product, that is 48 divided by the number of units of labor, that is 36. So 48 divided by 36, that you will get so that is equal to 8 by 6. So the average product of labor is 8 by 6. Then we know that marginal product of labor is equal to alpha into average product of labor. So here alpha is 1 by 2. That already we have derived. The marginal product of labor is alpha into 1 by 2. So alpha is alpha into average product of labor. Alpha is 1 by 2. So we can write. So this into 8, that's equal to marginal product of labor is equal to 8 by 6 into 1 by 2. So that is equal to 4 by 6, that is equal to 2 by 3. This is the marginal product of labor. Or otherwise, we have to differentiate the equation with respect to alpha. Then you substitute all the values. That way also you can find the marginal product of labor. But this is more easy because we know that marginal product of labor is alpha into average product of labor. So that is the answer for part B. Then part C. What is the average product of capital when k is equal to 16 and L is equal to 36? It's very simple. Average product of capital is equal to 48 divided by 16. So that is equal to 3. The next part, find the number of units of capital required to produce 40 units of output. So it is given that the output is 40. So we can write 40 is equal to A into, so A is 2. From the question itself, it is 2. And so 2 into k raised to 1 by 2. We have to find the number of units of capital. And L raised to, the value of L is given as 25. So we can write 25 raised to 1 by 2. By solving, we will get it's equal to 2 into k raised to 1 by 2 into 25 raised to 1 by 2, that is 5. So then k raised to 1, that is k raised to 1 by 2 is equal to so k raised to 1 by 2 is equal to 40 is equal to 40 divided by 2 into 5, that is 10. So k raised to 1 by 2 is equal to it is equal to 4. So k raised to 1 by 2 is equal to 4. So k is equal to 16. So we need 16 units of capital to produce 40 units of output. So in this way we can find all the values. Next is a question from the topic cost. The total cost function of a firm is given as TC is equal to 1000 plus 10q plus 6q square plus q raised to 3. First question is derive TVC, MC, ABC and AC. So you must remember what is total cost that we have already explained. Fixed cost, variable cost, marginal cost, average variable cost, everything we explained. So that should be in your mind. Then only we can do this problem. So we have to derive first total variable cost. So total cost function is given as it is 1000 plus 10q plus 10q minus 6q square plus q raised to 3. So from that we can say what is the variable cost. So variable cost is the cost that will not change with the output. So we know that the total variable cost is here. The fixed cost, from this equation we can total cost function we can say the fixed cost is 1000 and total variable cost is equal to 10q minus 6q square plus q raised to 3. So this is the total variable cost. And the next is marginal cost. So how we have to find marginal cost? To find the marginal cost, we differentiate the total cost function or the total variable cost function. So when you differentiate the total variable cost function, we will get marginal cost is equal to that is we are differentiating the total variable cost function, then we will get 10 minus 6q plus not 6q minus 6 into q plus 3q square. So that is equal to 10 minus 12q plus 3q square. This is the marginal cost function. Then derive the average variable cost. So average ABC is equal to TVC divided by Q. Total variable cost divided by the number of units of output. So that is equal to 10q minus 6q square plus q raised to 3 the whole divided by q. So that is the average variable cost. So that is equal to 10 minus 6q plus q square. So that is average variable cost, 10 minus 6q plus q square. Then average cost. So average cost is equal to total cost divided by q. So the total cost function is 1000 divided by q plus 10q by q minus 6q square by q plus q raised to 3 divided by q. So the average cost is equal to, that is equal to 1000 divided by q plus 10 minus 6q plus q square. So that is the total cost function. Then next part of the question is, what is marginal cost when output is 100 units? So to find that, just substitute the value 100 in the marginal cost function. So we have already derived that the marginal cost is 10 minus 12q plus 3q square. So to that equation, we substitute the value of q as 100. So then you will get the marginal cost as 10 minus 12q, that is 100 MC is equal to 10 minus 12 into 100 plus q raised to 3. So that is 100 raised to 3. So you will get when you solve this, so here 3 is also there, 3 multiplied by 100 cube. So that is equal to, when you solve, you will get 28,810. This will be the marginal cost. Then next part of the question is, find the level of output where MC is minimum. So that is the part D, find the level of output where MC is minimum. So for that, when MC is minimum, the first derivative will be 0. That means when you take the first derivative of the MC function, that is MC function is 10 minus 12q plus 3q square. The first derivative will be minus 12 plus 6q, 3q square, when you differentiate you will get a 6q. So that is equal to 0. So from this q is equal to 12 divided by 6, that is equal to 2. So when we produce 2 units of output, the MC will be the lowest. To prove that, we can take the second derivative. If the MC is minimum when output is 2 units, then the second derivative will be greater than 0. So we can find what is the second derivative, that is d2 So when you take the second derivative, you will get the value 6. So we differentiate again this equation. So we are getting the value 6. So that is greater than 0. So that is proved. So when output is 2 units, we can say that the marginal cost is the minimum. So that we have proved. Why? Because the second derivative here is it is greater than 0. So in this way we can find out the cost for we can find out different values for a total cost function we can derive variable cost, marginal cost, average variable cost and average cost, even total fixed cost also. So everything we can derive from the total cost function. Then sometimes you will get another type of question. It's not a problem, but you will get a schedule like this. Output, TC, TFC, TVC and marginal cost. So output 0, the total cost is given as 100. We have to find the total fixed cost and total variable cost. Then output 1 unit, total cost increased to 150. So we have to find total fixed cost and again total variable cost and marginal cost. Then second unit, it is 1, we have to find the total cost. It is not given. Total fixed cost also we have to find. Total variable cost also we have to find. The marginal cost is given as 40. Third unit, this we have to find total cost, total fixed cost we have to find, total variable cost is given as 120 and marginal cost also we have to find. See, when output is 0, the total cost is 100. That means that is the fixed cost. So this is 100. Variable cost is 0. When output is 0, variable cost is 0. No need to write marginal cost since output is 0. When total cost is 150 for first unit, the total fixed cost again it will be 100 and total variable cost will be 50 and marginal cost is also 50. Then for the second unit of output, you have only one value is given, that is marginal cost is 40. For the previous case, that is when output is 1 unit, the total cost is 150. So here for the second unit marginal cost is 40. That means the total cost will be 190. Total fixed cost again 100 and total variable cost is 90. So we got everything. And here it is for the third unit of output, the total variable cost is given as 120. So that means total cost will be total variable cost plus fixed cost. So 120 plus 100, that is 220. This is again 100. And what about the marginal cost? Here the addition is, the previous case the total cost was 190. Here the total cost increases to 220. So 190 plus 30, that is 220. So 30 will be the marginal cost. So in this way, to complete a schedule, that kind of question also can be asked. So be familiar with it. See the next question, it is from break-even point. So the question is, suppose a firm makes candles and every month it has to pay rupees 3000 as rent and rupees 3000 as interest charges. If the selling price of a candle is rupees 5 and variable cost per candle is rupees 2. So we have to find different things. First one, estimate break-even level of output. Finding the break-even level of output, we know that the QB, that is the break-even level of output, is equal to TFC divided by P minus AVC. So what is TFC? From the question we can understand that TFC is the rent and interest payment. They are the total fixed cost. So 3000 plus 3000, that is equal to, so TFC is equal to 6000, P is equal to 5, and AVC is equal to 2. So we have everything now. So TFC divided by P minus AVC. So that is 6000 divided by 5 minus 2. So that is equal to 2000 units. So this is the break-even level of output. Now next question is, if the sales is 5000 candles, what will be the profit? So for that, we know that profit is the difference between TR and TC. So TR minus TC is given as 5000. So 5000 is equal to TR. TR is price multiplied by quantity sold. Sorry, if the second part of the question is, if the sales is 5000 candles, what will be the profit? So we have to find out the profit. Okay, not profit is not given, we have to find out the profit only. So we know that the output sold is 5000 candles or 5000 units. So TR minus TC, that is equal to 5000 multiplied by 5, that is the price, minus TR minus TC. TC is the sum of TFC and TVC. So TFC is 6000. So 6000 plus 6000 plus TVC. TVC we can find, TVC is AVC into Q. So AVC is rupees 2. So 5000, that is the number of units of output, into 2. So that is equal to 25,000 minus 16,000. So that is equal to 9,000. So when the firm is producing 5,000 candles, their profit will be 9,000 rupees. Then the third part of the question is, to get a profit of rupees 15,000, how many candles are to be produced? So here again, the profit is TR minus TC, that is given. So what we can write, 15,000 is equal to 15,000 is equal to TR minus TC. So that is TR, that quantity multiplied by 5, Q into 5 minus total variable, total cost. Total cost is the sum of fixed cost and variable cost. So 6,000 plus total variable cost is 2 into Q. Q that we don't know, we have to find. So when you solve, you will get the value of Q as 7,000. So when you are producing 7,000 units of output, you are getting a profit of 15,000. So in this way we can find that answer. Then the next part of the question, if the sales is 5,000 candles, what is the margin of safety? Margin of safety is actual sales minus break-even sales. So margin of safety is equal to actual sales. It is given as 5,000. So 5,000 minus break-even sales 2,000. So that is equal to 3,000 candles. This is the margin of safety. Then next part, estimate profit to volume ratio and break-even sales. Profit to volume ratio or PV ratio. PV ratio is S minus V by S, or instead of S minus V by S, total revenue minus total variable cost divided by total revenue, we can take P minus AVC divided by P. So PV ratio is equal to price minus average variable cost, that is 5 minus 2 divided by 5, that is equal to 0.6. Then and break-even sales is equal to TFC divided by PV ratio. Break-even sales is equal to TFC divided by PV ratio. So that is equal to TFC is 6,000. 6,000 divided by 0.6, that is equal to 10,000. This is the break-even sales or break-even revenue. This 2,000 is the break-even level of output, that is 2,000 units, and this is break-even revenue or break-even sales. So in this way we can find the break-even sales. Then the last part of the question, if the firm wants to bring down the break-even output to 1,500 units, what should be the price charge? Now the break-even output is 2,000 units, but the firm wants to bring down this break-even output to 1,500 units. So what should be the price if the break-even output is 1,500? So we can write 1,500 is equal to TFC divided by P minus AVC. TFC is 6,000 divided by P, we have to find, minus AVC. AVC is equal to 6,000 divided by P minus 2. So when you solve, you will get the price as 6. When you solve this, you will get price is equal to 6. So that means if the firm is charging a price of rupees 6 per candle, then the break-even output will be 1,500 units. Otherwise, when the firm is charging a price of rupees 5, then the break-even output will be 2,000 units. So in this way we can find the price to be charged for bringing down the break-even sales to 1,500 1500 units. So in this way we can solve all, or we can find out all the different values which are asked in the question. The next question, suppose the monthly fixed cost of a firm is rupees 20,000 and its monthly total variable cost is rupees 30,000. If the monthly sales is rupees 60,000, estimate contribution and break-even sales. If the firm wants to get a monthly profit of rupees 20,000, what should be the sales? See, here the first part of the question is, if the monthly sales is rupees 60,000, estimate contribution and break-even sales. So here, yes, the total sales is equal to 60,000. V, the total variable cost is equal to 30,000. And the TFC is equal to 20,000. Now the question is, first part is, what is contribution? Contribution is total sales or total revenue minus total variable cost. So that is equal to contribution is equal to S minus V, that is equal to 60,000 minus 30,000, is equal to 30,000. So contribution is 30,000, and if you want to find break-even sales, then again we have to find out the PV ratio. So PV ratio equals S minus V by S. So that is equal to 30,000 divided, S minus V is 30,000. 30,000 divided by S, that is 60,000. So that is equal to 0.5. And break-even sales is equal to, or break-even revenue is equal to TFC divided by PV ratio. TFC is 20,000 divided by PV ratio 0.5. So that is equal to 40,000. That is break-even revenue or break-even sales. Then last part of the question, if the firm wants to get a monthly profit of rupees 20,000, what should be the sales? This is the break-even sales or break-even revenue, but the firm wants to get a monthly profit of rupees 20,000. So we have a formula for that. The sales for the sales to earn a desired profit. So that is equal to TFC plus desired profit divided by PV ratio. So here the TFC is equal to 20,000 plus desired profit is equal to again 20,000, that divided by 0.5. So you will get 80,000. That means when the firm sells for rupees 80,000, they will get a profit of 20,000. So in this way we can find the sales to earn a desired profit. So these are the various numerical problems that can be asked from module 1 and module 2.